Okay, welcome back. The next concept we're going to learn is the angle between two planes. We talked about angle between two lines. Now we talk about angle between two planes. So maybe I draw your attention to two planes like that. Alright, two planes like that. What we want to find is the angle between the two planes. Now what I'm going to say here is not really in the syllabus, but I think it's a good idea to know. Essentially, the angle is the angle we want to find is the angle between L1 and L2. This angle. Now, what is L1 and L2? First, L is the line of intersection between pi 1 and pi 2. This L. Now, if you can find L1 and L2 here, L1 and L2, such that L1 and L2 are perpendicular, are both perpendicular to L, where L1 is on pi 1 and L2 is on pi 2. Then the angle we are going to find is this angle between L1 and L2. However, in A levels, this is not what we're going to do. Okay, in A levels, this is not what we're going to do. The easiest way to do it at A levels is now we look at this diagram. I'm looking at side view. Okay, now maybe I can give you two planes like that. This is plane 1 and plane 2. Okay, I actually want to find the angle between the two planes. Now the idea is the angle between the two planes is actually the angle between the two normals. Now let you see side view now, and this is the diagram. Now go back to the screen. This is the side view of pi 1 and pi 2. Now, if I want to find theta, why make our life so difficult? Why don't we just find normal 1 and normal 2? The angle between normal 1 and normal 2 will actually give me the angle between the two planes. I think that's that. Nothing else to say. So if I have two angle or other equation of two planes like that, how do I find angle between the two planes? I just need to take normal 1, normal 2, find angle, and that's it. Now, what if I take n1 dot n2, I realize that I get a negative number. Then I realize that theta is a obtuse angle. What happens? Again, exactly the same treatment as you would, as you would do for your angle between two lines. Alright? It's the same as the angle between two lines. If it is acute, so be it here. If your theta happen to be acute, then good, you just leave it as it is. But if your theta happen to be obtuse, then you have to take 180 minus theta. Why? If you take a look at this diagram here, if I give you equation of two planes, pi 1 and pi 2, normal one may be like that. But if you so happen that the normal is given as this normal, you would have found this angle, correct? Because normal 2 is like that. If your normal 1 happened to be in this direction, you would have happened to find this obtuse angle. But very often when the question wants us to find angle between two planes, the question will always ask for the acute angle between the plane. Acute angle. All good? Yes? So let's use an example to illustrate. Example 3. The equation of the two planes are that, alright? Yes? This one and this one. Find the acute angle between the two planes. So we need to take normal and normal. Yes? Then you take dot product. You realize that it's a negative dot product. Then you will get an obtuse angle. Now this just means that if I say side view, this just means that your pi 1 is like that, your pi 2 is like that. Then you so happen that this is n1, and you so happen that your n2 is here. It's not this n2, not this n2. It is this n2. Then you saw, okay, then I took this one. Happen to get an obtuse angle. Never mind, the acute angle is just 180 degrees minus 119.017. In the end, you give the 3 SF, it is 61.0. Or rather, 1 decimal place. Okay? Usually, the question will tell you at the front page of the question, it will also say angles in degrees to be rounded off to 1 decimal place. Okay? Alright? So, but intermediate step, I would prefer you to give 3 decimal place for intermediate working. Okay? Okay. So we dealt with line and line. We dealt with plane and plane. Now what happens if the question asks for the angle between a line and a plane? So if you look up here at the camera again, this is a plane and this is a line. I essentially want to find the angle between the plane and the line. So let's look at this thing. It's a slightly more complicated, but not excessively so. Let's take a look. Case 1. First, what do? We will find the angle between the line, the direction vector of the line, which is this, and the normal. Okay, we find I repeat, the line and the normal. You realize that you will get this angle. But this is not the angle we want. We want the angle between the line here and the plane. Essentially, we want this angle. So all you need to do at the end of the day, because since the normal is perpendicular to the plane, if say I happen to find this angle, say it is 32 degrees. Then the angle between the line and the normal, if it's 32 degrees, then what do you think is the angle between the line and the plane? It must be 90 divided minus 32, sorry. Then you will get 58. Done. Correct? So if you happen to say you get 32, well and good. Done. The angle is just 90 minus 32. Done. Now there could be another case, case 2. What happens if you take angle between the line here and the normal? It so happens that you obtain an obtuse angle. It's very possible. If you look at direction vectors, it's possible that you get obtuse angle. Then what do? It's okay. Find the acute angle first. Yes. Then after finding the acute angle, take 90 minus the acute angle. And this alpha is actually 180 minus theta. This is the acute angle of our theta. I think this diagram sums it up. Maybe you would want to review it again if you really don't understand. Yes, but I think it's quite manageable. I would say manageable. So let's keep all this. I think the idea is there. So drawing a diagram actually helps us remind you to find 90 minus alpha. Because whenever you jump straight into a question without really understanding, you got a problem. Yes? So all you need to know now is I find angle between line and plane. To find angle between line and plane, first I draw a diagram. This is my line. This is my plane. I first find angle between line and normal first. Correct? And find normal first. So equation of plane is this one. This is the normal vector. This is the normal. Emphasize, this is the normal. Yes? Then when I take dot product between the normal and the direction vector of the line, yes, I will get a certain cosine theta. In the end, I cosine inverse, I get 144. What is 144? Diagram is super important. This is 144.7. Alright? First, I need to do this. I need to take 180 minus 144.736 I'll get 35.264. Now, what is 35.264? This is 35.264. This is 35.264. Is 35.264 the answer? No, 35.264 is just the angle between the line and the normal vector. It's the acute angle between the normal and the line. To find the angle between the line and the plane itself, I need to take 90 minus 36.264. I'm sorry. Yes, then I get 54.7. This is one decimal place. All good? Yes. So let's recap one more time. How do we find the angle between a line and a plane? This diagram helps. All right. First, I find angle between the line and the normal, because the normal is 90 degrees to the plane. Correct? So I find normal first. It's easier. All right. Then, if this angle happen to be acute, well and good. If it's 32, you take 90 minus 32, you're done. Sometimes, like what you see in example 4, all right, like you see example 4, sometimes you see, I take an angle between line and normal. In the end, I get obtuse angle. What do? We take 180 minus the obtuse, I get the acute. Then take 90 minus this acute. You will get the answer. Now, I think it's very important to answer this question now before we take a short break. Is this. You may wonder, if the plane equation is given as this, alright, this is the position vector 1 point. If you know your vector equation of a plane well enough, then this is a vector parallel to the plane, this is another vector parallel to the plane. Then you may ask, why? Why cannot? Since I know, that this is the plane, I know this vector parallel to the plane, I know another vector parallel to the plane. So now, if I have a line equation with this one, I take line equation of this one. This is my line. If I want to take the angle, you want to find angle between the plane and my line, I just use this is the direction vector, right? Direction vector of the line, this is the line. And I just choose any one. I just choose this one. I just choose this 101 here. And I take dot 2 minus 1 minus 2. Maybe I'll expand this one. Why can't I take angle between this line parallel to the plane and this line itself? Find angle. Reason is very simple. Look, this is your plane. This is your plane. This is your line. Now, there are many vectors that are parallel to the plane. There is only one vector that I need to... there is only one angle between the line and the plane, which is this tiny angle here, if you can see. This angle. But if I anyhow choose one angle, I anyhow choose this one, the black one, I will not get the angle. I will not get the angle between the line and the plane. I will never get it. I cannot choose anyone. I actually want to find the projection of the red pen, which is the line, on the plane first. Then I find angle between this one and the projection. That is the angle. But I cannot choose any random line on the plane. So cannot. So the easiest way to do it is to use normal. Don't try and be funny. Angle between normal and plane, then take 90 minus it. I go back to this diagram again. Sorry. Okay, I go back to this diagram again. Always use normal. In finding angles between plane and anything, always make use of the normal. End of story. Okay, good? Yep, that's that. And then next part we will talk about foot of the perpendicular.